Hi, I'm Kerry. I just finished a 35-minute interview with Rick Phillip, the CEO of Desktop Metals, and I learned more about Desktop Metals and the 3D printing industry than I ever could reading annual reports or the notes of annual reports or the quarterly statements. And this is where I want this channel to go. I want to teach you to fish rather than give you a fish. I don't want to give you a hot tip. I want to give you an understanding of an industry that is going to change our world, and that's 3D printing. And I think Desktop Metals is going to be the leader in that. You're going to learn a lot about this company that you didn't know. And so that's the direction this channel is going. It's going to be about a 35-minute video. I really encourage you to watch the whole thing and really understand Rick and his company and how it's made up and the intricacies that you probably didn't know about and where this industry is going and in where in specific Desktop Metals is going. Again, I'm Kerry Grinkmeyer. I'm the host of Best of Us Investors. We're a collection of people, I call them a tribe, that wants to make better investment decisions. And this video is going to help you make a better investment decision. Trust me on that.
Best of Us Investors presents Kerry Grinkmeyer.
I see 3D printing and robotics as a must for our country. So my first question to you, Rick, is help me understand your business better. I see three elements of it. One, the printers, two, the materials, and three, the software that runs
and the parts as well.
In your quarterly report, you break it down as 90% products and 10% services. What part of that is materials and parts, and what part of it is the actual selling of the machines?
So we have our business is essentially a high margin recurring revenue product business. So it's like a razor blade.
Yes.
Depending on the product that you're using, we've got a printer that is going to consume a certain type of media. In the case of the really high volume mass production systems, it consumes binder. The powder is actually not included. In the case of our more turnkey solutions, like a shop system, we include powder that we resell, but then we make the binder. That's the other consumable. From a breakdown point of view, services is includes the warranty and support and those types of things. But I think the rest is all on the product side. Where I don't believe we break it down to the granularity that you'd see the recurring versus the upfront. But and I can show you some slides if you'd like that kind of talk to the unit economics of different products. They're a little bit different depending on whether it's something that would go in a machine shop, something that's used for polymer mass production, which has different ratios of capex to consumables, and something that is used for very high volume production of metal parts or end-use metal parts. So I could describe the reasons for that. In the really high volume mass production of metal parts, a large Fortune 500 company wants to choose who they want to buy steel from and have multiple sources of that type of income. However, the machines still consume ink that is produced by us, and that's a very high margin component that goes into the printers.
Okay. I relate to that. I used to work for Polaroid, if you remember Polaroid.
Awesome. Yeah, that was a great company. Yeah.
Yeah, they just didn't understand where the world was going.
It was a great company for many decades. So
yeah, but we used to say we had what we called a color pack 2 that sold for about $25, and we always used to say we'd be happy to give you a camera if you would guarantee us that you bought a pack of film every month for the next 3 years. And that's what I kind of see the 3D printing business as.
It totally is, yeah.
Okay, so you're generating a reoccurring revenue. So
Every single product. So I'll give you the ratios. And actually, I could maybe pull up a slide that shows you, because it's on a per product basis. It changes a little bit, but for example, on a very high volume mass production system like a P50. A $2 million upfront sale will generate about $6.5 million in revenue over the life of the product. 3.8 million of that is essentially consumable, which is very high margin. That is the ink that we inkjet. Now, in that type of product, we don't sell the powder, the steel. We're not vertically integrated into powder yet, although we've talked about doing that. But that consumable would be a multiple of. I mean, that machine, processes over 0.5 metric ton of powder per hour. So if we're not in the, we're not requiring those customers, let's say a major vehicle OEM, that they have to buy that powder from us today. We do it on the small machines, which are more closed, turnkey, walled garden type systems. So, and then if you look at it, the ratios on the photopolymer side are even better. Our highest speed production photopolymer system, the Extreme 8K, $150,000 sale would be about $112,000 to us. That machine will generate about $1.6 million worth of revenue over 7 years, over the life of the product. And all that revenue is the consumable. So the film is a much bigger business. It's almost 14 times the upfront revenue. So you could almost, in a way, yeah.
What excites me about that is once you get the penetration, once you convince the industry that this is the way to go, your revenues are just going to continue to grow.
You have a pretty reliable base of consumable revenue that flows. Now, if you're growing very fast, then you always have a lead in with hardware. And usually our hardware is 50% gross margin in most of our products. So you're leading with hardware, and then you've got to follow on with the consumables as people use the product. In a product like the shop system, which is a turnkey metal system, it's about 1/3 of the upfront sale per year in the consumable. In a product like the photopolymer systems, because those are very inexpensive to acquire, the bulk of the revenue later on is on the resin. Materials that those systems consume.
You mentioned that the 7-year life expectancy, I guess, of the printer. So I would assume that another big part of your business is that you got to be working on the improvement of the next generation of your product.
That's right. Yeah.
I noticed in your first quarter report, you made a major investment in what they just said investments. What was that all? And it actually took a very profitable quarter and turned it into a negative return on your earnings per share. What was that big expend? And I also saw your employees grew dramatically.
Yeah, so a few things happened in Q1. First, we acquired Envision Tech, which is the original inventor of DLP photopolymer printing. And they have significant IP and a significant fast-growing base. It's a very good company, and we're going to do great things together with them. The second thing that happened is the SEC issued the guidance on warrants and how they're classified for companies that went public via SPAC. And so there was a non-cash reclassification of that, and we filed their appropriate paperwork, and that's what you see with that dynamic on our numbers. But I think it's a non-cash event. We just had to comply with guidance along with probably several hundred companies that had to do the same thing. So, I think it changes that on one quarter, and the next quarter it's the reverse. So
I follow a number of 3D printing companies, and it seems to me that as I read about you, you're all looking for your niche. Some are choosing to get into mass production, particularly like the automobile industry. Some are looking to get into custom production, like the medical and the dental industry, orthopedics and such. And then others are getting into very high level rocket ships and things of that nature. Where is Desktop Metals going? Where's your focus?
So our focus is what we call AM 2.0, which we define as mass production of end-use parts. So this industry had a few waves. The first wave of the industry was sort of before 2006. It was in a research phase. And then from 2006 to, I would say, end of last decade, it was in a mode of applications like tooling, jigs and fixtures, aiding the manufacturing environment, prototyping. And I would say that is producing a prototype of something is really not what we do at DM. We have developed processes that are cheaper than conventional manufacturing at given unit levels in order to enable broad adoption of additive for end-use parts. It's the fastest growing segment in our industry. We're growing much faster than our market. So this is a market that compounded before 2006. It was compounding at 9%. From 2007 through I would say 2017, it compounded around 20%. But the industry was very small at that time. The entire industry at the turn of the last decade in 2010 was about $1 billion. So it was a very small industry. There was a hype cycle at that time. And a lot of technology went off patent. Some of the early companies suffered from that. And then most of the innovation from 2010 to 2020 came in private companies that were venture backed, like us and a few other companies. And then other people also innovated, like HP, for example, did some great things in the past decade. And then really now we're entering a new phase where the technology is mature enough and fast enough to go to mass production. That's where we lead. We have the fastest printers in metal that produce the lowest cost parts and can do it at a volume that you could actually go to volume production with. We have the world's best, fastest, and largest area-wide photopolymer systems. Those are fantastic platforms. They are really, really, they're spectacular platforms to mass produce plastic and polymer and elastomer parts. And in that world, for a long time, you've had the ability to make good-looking polymer parts. You just never had the mechanical properties, the combination of surface finish, the tolerances, and the mechanical properties and throughput to make it work. And it's been a very interesting development in the past 2 years when people have introduced photopolymers that are multi-cure that actually give you the mechanical properties that match thermoplastics with that process, or exceed it. And that's what prompted us to make a move in the photopolymer space. It's been, technology is now matured, and so you have a combination of speed, accuracy, surface finish, and now cost and properties to really go to volume production. And it's taking off in many markets, like dental, for example, is a market where there's $38 billion worth of parts sold every year from labs to dentists. And today, a fraction is printed, but this decade, I think by the end of the decade, everything will be printed. And that's a great market because it's a patient-specific market. Every single part is unique and different. So what that's created is an environment where, it compounded at 20% the last decade from roughly $1 billion to about $12 billion. And now it's at some reasonable scale at $12 billion. And this decade, last 3 years before COVID, it compounded at 25%. It's projected, we're now at around a 25% CAGR as well for the industry as a whole. And it's projected that will continue this decade. So depending on whose forecast you look at, it's about $150 billion market by the end of the decade. So it's a major transition and a significant growth in adoption happening, not just in select customers, but across the board. So if you make products for end-use part mass production, it's very attractive. Now, you were asking the question that some people are looking at rocket ship parts, some people are looking at tooling, and some people are looking at end-use part mass production like us, high volume production. I think that the tooling market, for example, is very niche. So you could take an old player like Stratasys and try to disrupt that. I think you have a ceiling in how big you can make a company. If you have relatively slow technology, you may take share from Stratasys, but it's not something that can grow to be, tens of billions of dollars. So I think that making parts for rockets is a real business, laser powder bed fusion, but it's a very slow process. So, outside of turbo machinery and some other applications like orthopedics, it may be a limited market beyond that. But there are great companies that are growing, and I think definitely. But our view is that the real opportunity here is to enable a broad set of materials. We have 225 materials that are printable today, and they range from a variety of metals, ceramics, photopolymers, wood, elastomers, and then enabling that to be used for mass production of end-use parts. So that is our core focus, is to develop approaches to print parts that give you the combination of properties, cost, surface finish, and throughput that allow you to go to volume production cost competitively or cheaper than conventional manufacturing like casting or machining or other approaches that people would use today.
I saw an interview with your co-founder, Jonah Meyerberg.
Yeah, great guy.
He made the statement that really kind of blew my mind. He said that there were roughly 30,000 parts in a Ford in an automobile, and he projected that roughly 1,000 of them were adaptable to 3D printing. And I looked up, and I think Ford makes something in the neighborhood of several million automobiles a year. Do you see the day when those 1,000 parts multiplied times 10 million vehicles are all 3D printed?
I do see a day where a significant percentage of a vehicle could be made without tooling, and you can rev designs faster, and you could also save cost and create shapes that are more efficient, and simplify your supply chain by not having to ship things around the world, but sort of print locally and assemble. Today, you have local assembly for much of the automotive world. Now, if you look at where we are in 3D printing as an industry, we are entering a world where you can mass produce individual components less expensive than conventional production, up to certain volumes, like 100,000 units versus casting in our world. So that starts to open up segments of the auto space. It's about 20% of our business today. I don't expect it to. Now we have a broad business in other areas, consumer electronics and oil and gas and many other applications for this technology, medical, et cetera. So all of them are growing. I don't expect us to be an 80% automotive business or 50% automotive business. And actually, I don't like businesses that have high account concentration. I want to have lots of customers. And in particular, I think adoption by small and medium-sized businesses is the real proof that you've got a valid manufacturing process that's at scale. Because one of the things that happens in additive is that you can have a center of excellence by a big company, and they'll buy one of each. But really, when a small company makes a living off of your equipment and can do it profitably, then you've got something. You got a fast payback. It makes parts that they're happy with, and so we see adoption like that, and that's something that is quite exciting.
That's interesting. That I guess I thought it would go the other way.
It is going. What's happening is both are happening. We have business with Honda, Nissan, Toyota, Ford, BMW, GM, et cetera. We have engagements in customer relationships and with lots of vehicle OEMs and tier ones. But at the same time, you have machine shops down the street or small parts makers that support Boeing or luxury good companies that are utilizing the technology, and they do it successfully. So I think we had a case study of a company in France that supports manufacturing of parts for luxury goods like Chanel and Louis Vuitton and people like that, all the ornaments that go in their products, the little metal ornaments. And they make like 70,000 parts a week. That's a real number for a small company, right? So I get excited about that because that is the world. I mean, if you're doing that, then you know you've got something that's scalable.
Let me understand your acquisitions. What is it? Envision Tech and Additive 3Ds and Forest. I understood Forest. You sent me a wonderful video on that, and that was just cool. Are these is this the materials? Is that what you're buying there? Antiques and materials?
We have this is I'll describe the strategy. So we have a slide on our deck that shows three bubbles: printers, materials, and parts, as part of our growth strategy, and then how they interplay with each other. You want platforms to produce the product. In the case of the Polaroid analogy, would be camera technology, right? We try to do that ourselves internally. That's part of our core business in metals. We acquired the leader in photopolymers that had invented the area-wide printing process for that technology. And so now we have polymers and metals. The polymer products can do elastomers as well as rigid polymers. So we acquired the world's best elastomer printed material. It's technology that came out of DARPA. That's a company called Adaptive 3D. And if you look at the last slide, there's a chart that describes that transaction, has some select customers, and it has one of the charts in the back of that presentation shows you the mechanical properties of, which is elongation versus tear strength, of those products versus all the competitors. And you'll see that they're far ahead of anybody else in the industry. And so what that gives us is a combination of superior properties of the materials that are produced, combined with highest throughput, which is what we get with the Extreme 8K platform from Envision Tech. So you've got best-in-class throughput, best-in-class properties, and an industry that is quite disruptive. You could also reframe this as focus on killer apps. So killer apps for additive would be things that can only be done with additive. One of them is the ability to print metamaterials. Those are essentially lattices. I don't know if you've ever seen a lattice. It looks like a lot of unit cells that are interconnected, and you change the properties of that material. So if you're doing something that's an elastomer, you could make a part behave differently in different sections of a part and deliver very specialized performance. Different people do it in sporting goods and shoes and many other markets. And the combination of those two companies allows us to have a best-in-class solution for that market. You look at Forest. Forest was a very small acquisition, technology developed at UC Berkeley by the chair of the architecture department. And it's a process to print wood. It uses the existing printers that we already make for metal. So we didn't have to invent a new machine. We take our binder jet process for metal, and instead of inkjetting a binder, we inkjet lignin. So that, just for the viewers that may not understand this process, it's a really spectacular approach. You take the components of wood, which is lignin and cellulose. And when you make paper, you separate that, and you throw away the lignin and you use the cellulose to make pulp. This is that process in reverse. So here you take waste, which is lignin, and you take cellulose, which is sawdust, and then you're printing the lignin into the cellulose and reconstituting the wood in the printer. And you can make photorealistic wood with properties that are, stronger than most trees. So stronger than pine and other softwoods. It's not as hard as the hardest woods, but it's somewhere in the middle, but it's definitely a structural material. So you could make furniture. And that has been those parts look incredible. I encourage you guys to look at them if you've got some. They enable you to very cost effectively make parts at incredible economics, because the raw materials are almost free. They're basically waste that's being upcycled, just paying for the shipping cost of moving them from one location to to another. So it's a super green process. You're not killing trees. So today we have half the number of trees we had on planet Earth when we started the Industrial Revolution. And on top of that, we have global warming that's creating all the problems. So I think it is a pretty cool process to mass produce parts. And it turns out that wood business is large. I mean, $1.3 trillion worth of finished goods are made out of wood every year. So we've had incredible demand for that product since we launched it. I think it'd probably take a quarter or two to know how much of that can be converted, but it's been unprecedented for us. So I'd be completely surprised by how well received that product has been.
I heard you refer in an interview to your 200 partners. And is this, what does that mean? Who are your 200 partners?
Yeah, so one of the things that we do something a little bit different than our competitors. The legacy companies in our space sell through direct sales. They have like a staff of folks in different regions, and they cover different regions. We have an indirect sales model where we have 200 partners in over 60 countries that sell our products. And that gives us much bigger scale in scope to be able to be in front of more opportunities. So we're within 1 or 2 hours of every manufacturing site in the country today in the US, and we can get people there and you can support them in the US. And that's easy to do when you have a direct sales force in the US. But as this business becomes global and a lot of the manufacturing of products happens globally, it allows us to, if you have a customer in New Zealand, you can actually have somebody local that can go meet with that person, close the deal, support it, install equipment after it's done, versus kind of the way that it was done before this. A sales guy would have to wake up at 3 a.m. to talk to that customer, and your support staff maybe was not covering that region of the world yet. And it's so I think, different industries have gone through this iteration. If you go back to the networking world in the 90s, Cisco created a similar model, and then that gave them an advantage from a point of view of reaching everyone around the world quick. And when new technologies came along, they were the natural acquirer because they had that feet in the ground globally. And so building that network has been a significant effort, and I think it's a significant advantage of our company. It is different than people that sell. The first wave of additive did have some companies that sold indirectly like this, but they primarily tapped networks that sold CAD software or products like that. And that's good if you're selling prototyping. But if you're selling mass production equipment, it's like a different animal. You want people that sell things that go on a factory floor. And that's really what we've built.
You touched on the software. I see that some companies that I follow have entered into collaborations with companies like Materialize, and they provide the software that kind of manages and programs the production of the machines. How do you approach that end of it?
Yeah, we're open. By the way, Fried's done a great job with Materialize. They're a good company. But we work with Materialize, we work with Autodesk, we work with other innovative companies like Topology that do specialized software. And I had a background investing in this area before I started this company. So we, in my previous business, we were the original backers of several of the leading 3D software businesses, and we did quite well in that business. So I would say, we have very specialized software that is unique to our products that nobody else has, like the ability to simulate sintering and what happens during that process in order to get accurate parts first time around. That's technology that nobody else has. However, we have, I would say, a view of the world that you want to leverage innovation on the software side as it comes along. And we offer all of our machines with a build prep system. The Materialize core product is a build prep platform called Magics. So we offer our machines with a turnkey solution that's ours. But if you wanted to add functionality to let's say put serialization on parts or develop special workflows, then you can always upgrade and get a materialized system, and that's compatible with our systems. Or Autodesk makes a product called NetFab that's also quite good to do this thing. So there's a variety of solutions out there, and we're compatible.
So this would be another source of reoccurring income.
Yes, correct. Yeah.
Okay. I like that. It just seems to me that Netflix, I pay them $19.99 a month, but so do millions of other people, and that's the kind of businesses I like.
This definitely is every single product we sell has a recurring revenue stream and a high margin recurring revenue stream. So it's just a matter of time till you have a large enough installed base, and then you have a great business.
The coronavirus has pointed out that our supply chain is broken. The government has basically said that they are going to correct that. Do you think that'll come into your business? Do you see the government in some way subsidizing, helping you convert people to 3D printing to bring manufacturing back to the United States?
I mean, I am very much a free market person, and I think that there are good policies that can be implemented to basically promote different approaches to doing business. But if the government did nothing, this is a very fast-growing business, and I think there are things in the infrastructure plan that that hasn't passed yet, but depending on what happens, could be quite beneficial to additive manufacturing, and we will see what happens. So I would say not having to pay tariffs and not having to ship things around the world and generate emissions is a significant boon to printing. And also, even if you have to ship the raw materials, you're shipping something that's with much higher tonnage. So you're utilizing that volume more efficiently instead of shipping air, which is what happens when sometimes you ship a component from Asia to the US or whatever. So where you've got the packaging and the sort of efficiency of moving materials is not as good as when you ship the raw material that gets converted to a final part.
Wrapping this up, I've taken a lot of your time. I see you in a extremely changing industry. You basically said that the life expectancy of today's printer is 7 years. What I was not able to find out is what percentage of your revenue are you putting into research and development? Do you see that changing in the future?
So this is one area where we're leading. We probably have the highest investment of any printing company in terms of investing in R&D in the market today, and have had for several years. We're extremely well capitalized, and we are a company built by technologists. I'm an MIT grad. Four of my co-founders are professors in the faculty at MIT. Adaptive 3D, the company we acquired, came out of UT Dallas, started by a professor who invented this new chemistry. So we are definitely a highly intellectual chemistry and material science driven, kind of like Polaroid, if you think about it. So there's that, but probably in the earlier years, right? Yeah, like in the 50s and 60s and the 70s and 80s. So
I want to share with you, I was one of their leading salesmen, and I was invited to Cambridge, Massachusetts. Mm-hmm. And I had dinner with Dr. Edwin Land. He sat right to my right. And I said to him in 1977, I said, Dr. Land, where is photography going? And he said, Kerry, in the future, a student will go to a lecture, and as the professor writes on the blackboard, he will get up after class and take something out of his pocket and step up and take a picture of it, and then go back to his dorm room and plug that into a device, and he will see that image. Dr. Land just described in 1977 the iPhone to me. He did not know what he was describing, though. And he actually had meetings with Steve Jobs, and they didn't get along. And that was the demise of Polaroid. So I guess the lesson to be learned is pay attention to these young people who have these bizarre ideas of what the future's going to look like.
Absolutely. Yeah.
Changing so dramatically. I like to say the next 10 years of change will equal the preceding 100 years of change.
I think that's accurate. It's exponential for sure. Yeah. I think that the one thing is that we tend to overestimate the short term, underestimate the long term. Right? Yeah. So if you think of the first, I guess they were called PDAs before the iPhone, right? The Sharp machines or the Palm Pilot, or, you didn't think it would become as pervasive as it is today, right? At some point it flips. That's some of what we're seeing in additive today. When you see small companies adopting the technology as a fait accompli, and they use it to make their components, and it's cheaper than getting a tool and cheaper than casting. You don't have to wait weeks for the parts to come. I mean, it's a very attractive process.
Wow.
So it becomes organic. And I'd rather do that and have 1,000 of those case studies grow than like put all my business development effort into one single opportunity. So I think it gives a better pricing power. And then you have, like you said, more sockets that are going to generate revenue because it's all recurring.
Yeah. Yeah. Well, Rick, I want to thank you. This is delightful. I think I feel proud that I think I am opening people's eyes to what your industry is all about, and that what you've shared with me just excites me.
Thank you, Gary, and you're welcome to come visit.
Oh, okay, I will.
Awesome.
Excellent. Thanks.
All right. Wonderful. Thank you very much. It's a pleasure.
All right, Rick. I will come.